Hi Dragan, how you doing?
Hello, Jerzy. I'm doing well. How are you?
All's great. Thanks that you found time to speak with me, especially when you are outside. I guess after lunch. Um, how's the summer?
Oh, summer is really hot here, but today it's a bit less hot, so it can be all right. And now I'm by the river, unplanned, but this is a contingency plan. I had to make whole from here, so I hope it is
Okay, okay.
technically possible.
Yes, so far the connection is good. So let's start with a question about you because not everybody might know you and your work and what you are doing for the community. So can you please introduce yourself?
My name is Dragan Djuric, and I'm a professor of software engineering at University of Belgrade, and I use Clojure as my main programming language and development ecosystem, and I've been doing it for quite a while, like some 17 years ago I started with it, and so far that's the best technical environment that I've found, uh, and so that's why we.
Oh, great, great. Before we will jump to closure, can I ask what do you teach in the university?
Well, I teach software engineering, so mainly some programming courses, but also AI because my lab is AI lab. Like much before this AI hype that came here.
Yes.
So my PhD was a mix of AI and software engineering, like 25 years ago. Uh,
Okay.
so,
Okay.
so yeah, mainly I teach, and I introduced. Maybe you didn't know that. I introduced courses based on Clojure at my university in 2010, I think, was the first year that I started. And
Oh,
for the last 17 years, I was also teaching Clojure in all my courses. I introduced this by force, so but students find it a bit unusual at start and confusing, but by the end of the course, uh, many of them love it. They they uh,
oh yes.
they can they have it's very difficult to find jobs in Clojure here. But as far as
Yes.
technical side of things, they love it. Even 10 years ago, some students started a few companies based on Clojure here in Serbia, and it did go well for some times, but later, like there are so many technologies, and unfortunately, these companies work for like outsourcing companies or like contractors. So basically, they have to use technologies that are mandated by the client. So
Yeah.
well, that's a curiosity. But here in Serbia, we have lots of programmers that know some code because they pass through my course. They are not. They're
It's a
usually
surprise
not
that
experts. They are not experts, but they know
yeah.
enough to know what it is.
Yes, yes, that's great. It's surprising that Serbia is not more visible on the map, given now universities don't teach lists all that much anymore, which is a big shame uh, because it's great. And actually, even if you got to machine learning development 25 years ago, Lisp was already there doing plenty of things, even 50 years ago, right? Um,
Lisp's time was much before that. Maybe
much before that.
in the 80s, already in the beginning of 2000s, it was mostly Java or C++ or something like that. It was before GPUs, and it was more like traditional. That was even the time before machine learning took off. I think machine learning took off maybe in late 2000s, if I remember correctly. And before that, it was
Yes.
semantic web. It was some symbolic technology, uh, some things related to web, because the web is
Yeah.
was expanding a lot at that time. And technologies was mostly Java. And it was an interesting time because people were trying to do these applications with traditional technologies like Java, which was
Yes.
not really capable of doing it well. But then came a great interest in alternative languages. And that's how I discovered Clojure, which was right about the time of Clojure 1.0. I'm not sure when exactly I started using it. Was it at the beginning of 2009? Probably early 2009. I'm not quite sure, but at that time, and I remember
Yes.
that maybe Clojure 1.0 was published, and I tried to do some machine learning applications before that in Java, and I had to develop all kind of exotic libraries for that, and it was kind of functional, but not quite. But then came Clojure, and I immediately recognized that this language, which is simple, provides many of the things that I felt was needed for me for the things that I had to implement and I wanted to try in a much simpler
Hmm.
way. So it was like this is much better than the stuff that I imagined that I need. So it was like that's it. Why wouldn't I start using it? It was the answer to my
Yes.
technical problems. So I switched immediately. I think in less than a month, I completely I learned basics of Clojure. I switched to Clojure exclusively, and I even published a scientific paper based on Clojure in IEEE magazine. I think it was IEEE software for some special issues. So,
How
I'm
was
curious,
how was Clojure back then?
how was Clojure? You
Um,
mean how was the language or the community or?
yes, the community ecosystem overall, like what was the spirit?
Well, it was interesting because at that time, obviously, there was much less content and much less information. But on the other hand, most of the content and the information and people who presented something or wrote something about something else, they had some interesting to say. So today, I feel not only with Clojure, but any content, any technical content, and I imagine any content at all, it's filled with some marketing bloat, with lots of AI generated slop, with lots of companies trying to sell some product or service or whatever. At that time, there were only a few communities that you can follow to get interested in information, but these communities were really concentrated about interesting stuff. For example, at that time, I took, let's say, most of regular information from Hacker News, which at that time
Hmm.
was much more interesting. Maybe I even heard about Clojure there. I'm not so sure, but it may be. And then Clojure was just the mailing list.
Yeah.
I would open Google, what it's called, Google Mail. It exists today, but not many people now go there. An open Clojure
Yeah.
mailing list, and you would see maybe two or three or five topics a day or something like that. Quick read, but then you will have to think more about that. Someone would write something like in two paragraphs or so, but then you would read it and you would think about it. Now there are tons
Yeah.
of text, tons of videos, tons of content. You don't have time to read or watch it, and you don't think about it. You watch it and then go to something else. If you watch,
Yes. Yes.
that's the problem.
Even when I think that um, there were times that there was definitely more hype around Clojure. I think the peak was actually around 2015.
Yeah.
This is where people were speaking about Clojure the most.
Hmm.
Um, and it was because people were interested in functional programming. Then mainstream languages adopted plenty of those concepts from functional languages like anonymous functions, higher order functions. Uh, but Clojure is attractive for many people since then for other reasons, like being highly practical language compared to some other functional languages where many things are quite a ceremony. While
Hmm.
in Clojure, you especially side effects, working with files, etc. It's very easy in Clojure. And Clojure in this resembles way more, let's say, traditional mainstream languages. While, for example, algorithms with software transactional memory, with immutable data structures, this part is very pure and very functional. So it's an interesting balance that attracts certain people who love Clojure, and it's hard to move away from it. So one of your focuses is programming for GPUs. What's the situation for somebody who wants to do GPU development
Hmm.
in Clojure?
Yeah. Well, uh, maybe my answer will be a bit longer, but it might
It's
be
fine.
interesting for this kind of content. So when I started using Clojure for GPU, it was in, let's say, 2014 or 13 or something like that. It was a time when it was discovered that for machine learning algorithms, that specifically neural networks, but other computationally intensive algorithms, GPUs can answer for that. I mean, if some algorithm would run 10 minutes on the CPU if implemented correctly and efficiently, and you could make it run on the GPU in like 10 seconds, it's a huge benefit, especially uh, if you can implement the GPU even in a simpler way than on a CPU, which is possible for some kinds of algorithms. But at that time, it was uh, difficult uh, to write GPU code in whatever language on the CPU, whatever, or on the C++. Don't mention Java. And Clojure was like it maybe as a proof of concept someone did it, but you cannot find any solution for that. So I had to develop my own. That is one of the qualities of Clojure that I like the most. It's not about the features. Like Clojure has like software transactional memory, or Clojure has this, or Clojure has that. The main thing about Clojure is, as you said, really minimal ceremony. So if you understand the problem well, you have the tools to create your own Clojure feature that is integrated in the Clojure itself. That's something that only Clojure and other lists, I suppose, have. That it is very minimal. You can mold it just in the way that you need. The trouble is, of course, for 99% people, is that okay, but you have to know what you want, what you do. So you have to understand the problem well. But being from academia, I had this sort of approach. Okay, I will make my own GPU environment. So I use some Java library to access GPU, and then I wrote my own C++ and C code for this sort of libraries, and I integrated this in Clojure. So I started, I integrated OpenCL in Clojure, but really integrated, not like just created some wrapper. Because if you create a wrapper, you still have the same bloated code just in Java. And if
Yeah.
you use Clojure interrupt directly, you still have this bloated code just in Clojure. So my goal is to automate whatever could be automated. So if you use Clojure, you get everything under the hood automated, so you can use it in a really high level. But also I leave hooks from the top to the bottom layer. So if you need more control that you cannot get from the automated pipe, you can get one level below. Write a bit more code, just a bit more, get more specific functionality. If that is not enough for you, you can go one level below. So
Yeah.
I created this multi-layered, let's call it cake, where you can work in the level that you feel is the right for your problem and the thing that you want to create. So with GPU programming is the same. The thing is that there are two parts. There is a part called GPU kernel that you write typically in C++ or in OpenCL. You write in C++, it's really limited subset of C++. This is the code that runs on the GPU, these many GPU cores, which are dumb cores, but there are so many of them that your code would be really fast. And there is also a management part that is typically in CUDA written in C++, but you can write it in many other languages to interop. And that part, in this case, is written in Clojure. So if you use one of my libraries, you would typically write some C++ for the kernels, because there is no sense translating that to Clojure. But then for the management part, you would write that in Clojure, and it will be much shorter than in other languages, and most of it is automated. And there are lots of small things that you don't even see that happen there, that you don't have to think about or do it by hand. But then I build layers on top of it, because it's only for GPU programming. But often, let's say most often for Clojure is, you wouldn't even need to write your own GPU code, because probably you need some stock algorithm, and someone has already written that algorithm. Maybe there is a library. So that's why I have libraries such as Neanderthal that offer many algorithms that run well on GPU. So it will run on GPU. You don't even need to do anything. You just call the same function that runs on CPU, and it runs on GPU. But of course, with GPU code execution, there are lots of ways that you can shoot yourself in the foot, because most often the code runs well, really fast, but the most difficult part is how to be sure that your data is at the right place, because GPU computes data that is on GPU memory, and your data typically starts from the CPU memory. So people usually do this naively and then kill all the performance that you get from the GPU computing. They kill by just using memory in the wrong way. So my libraries make
Yes.
sure that it's really difficult to make the wrong choice. And
Yeah.
they
I
automatically
actually.
pick the right stuff for you and everything else. But you still then okay, it's easy when you know what you want to do. But then the problem for most
Yeah.
people is, okay, but what do I want to do? So we come
Yes.
to the math
Yes.
part. So okay, this stuff is awesome. There are lots of functions that are really universal. If these functions are not enough, you can write your own with a small subset of CPU code, like 10 lines of or 15 lines or 100 lines of CPU code or of C++ code. But then, how do I use these to give the answer to my client? Okay, you should buy these stocks or whatever they do. Well, that's up to you. So you have to, let's say, uh, usually these kinds of problems are solved by some algorithms, whether these are machine learning or statistics or some custom algorithms that you invent. But usually these algorithms are described by some mathematics, usually some x's and y
Yeah.
and z. And most often for statistics and machine learning, these algorithms are written as vector algebra and matrix
Yes.
algebra.
Yes.
Even if you go to the book that describes how these algorithms work, there will be, like, let's say, 5 formulas, which are not really complicated, but they will be complicated if you try to naively implement this with loops and typical programming
Yes.
tools.
Yes.
But they usually translate more or less directly to some functions from my libraries. At least 80% of these will be able to, the, maybe sometimes even literally you translate the formula into calls for my functions. But you have to have some experience with this. You have to start from some build intuition, like with mathematics in university. You can learn it by rote, like by remembering formulas, but this is the bad way to do it. You learn it by solving problems and learning how to think in these functions, these matrix functions and linear algebra, and but over
Yes.
time,
Yes.
usually when I create some solution, it's mostly not much code, because most of the code is under these machinery that computes automatically whatever is the right thing. But you have to pick the right one. It's not simple. Like in the anecdote, when there is let's say the owner of a big factory found himself with the factory not working because the most expensive machine is broken, and he calls the expert, and the expert looks on the machine and he says, "Oof, it's a tough problem. It will be $1 million to repair it." What? It's too expensive. But the owner has to pay it, because otherwise many more millions are lost, because
Yeah.
the expensive factory is not working. So he says, "Okay, yeah, I have to pay. What can I do?" And the expert goes and takes his screwdriver and his hammer, and just does a little bump to the right place, and the factory starts working. And the owner says, "Oh, well, $1 million, but you repaired it in a minute." He said, "Yeah, but I have to train for 20 years to know how to repair it in a minute." So
Yes.
it's the same situation. So it becomes really easy when you have lots of experience and you know really how to read these papers and formulas and etc. But then you have a really powerful tool set under your belt.
Yes. Yes. Which at the same time, like you have built a couple of libraries that are focused, like Neanderthal is mainly matrix linear algebra, deep diamonds are tensors, deep learning, and so on. So before you start building those libraries, you also become the guy who really understands it deeply, or are those libraries for you a way how to learn yourself?
Well, both. Usually, I created each of these libraries to be able to do something that I needed to do. So I had to create the tools that I use to solve the problems that I have. But then, of course, I don't only implement the parts that I immediately need. I plan in advance. I have a feeling what I will need in the future, and also what other people need. And some things I don't even need, but I do it for not only for fun, but for learning and for completeness. So Neanderthal on the surface API may look like it's big. It's like 100 functions or more, like 200 functions. But that's only a tip of the iceberg of what is underneath. So because
Yeah.
alternative libraries have some of these have millions of lines of code in other environments. Neanderthal itself, it has only 20,000 lines, and most of these are really general, like heavy macros and functional, because I really squeezed every opportunity for generalization, because otherwise it would be too big for one person to even understand. Not talking about developing it or maintaining it. But I had to really make lots of effort to don't repeat myself, because there are lots of functions that on the surface is one function for the client that calls it, but on the surface underneath, that function has to pick the right algorithm for the structure at hand. So maybe it's a function for multiplying two matrices, but there are many kinds of matrices and many combinations of these matrices. And then I support several environments, like I support NVIDIA GPUs, AMD GPUs, Intel GPUs, CPUs, several kinds of CPU backends. So basically, for each function that you would use, there are maybe 20 or 30 different paths that could be taken. And each of these had to be optimal and fast. So it really took a lot
Yes.
of effort. And I learned a lot developing it. So, but the result is that Neanderthal is not only a linear algebra library, like everything you would need related to vectors and matrices and vectorized algorithms, and really exotic cases there. For example, what if you have a super large matrix and you need to take a subset of this matrix, and then you just take one vector of this matrix, and so I made sure that you don't have to do anything by hand. You just select this, and then all our algorithms adapt to it, because it's all polymorphic under the hood. But then also with Deep Diamond, so it does the similar thing with tensors. The tensors are, in theory, it would be okay. Tensors are just matrix with more dimensions. It
Yes. Yes.
might be.
How
It's not.
does
It's not. It's not. It looks like. Not,
how,
but even if it was, the
how
thing is
does
that
mathematics over tensors differ from mathematics over vectors and
well,
matrices?
the thing is that we as programmers, when you say matrix, you imagine a two-dimensional array, but in mathematics.
Yeah. Yes, as a mathematician, or I know that MATLAB and so on, they actually use one line of numbers, and those indexes are just multiplies
But
for those dimensions,
But this
right?
is just an implementation detail. But in mathematics, vectors are not even defined as a data structure. This is
Mhm.
just some abstract thing that, in a combination with a couple of operations, some things happen there. I mean, if you have some rules that are satisfied, this is the vector space. Whatever it is, it could be a glass of beer combined with operation of pouring beer in another glass. Whatever. I'm just uh, taking a wrong example of out of my head to just give you a feeling. What could, vector field doesn't have to be. even a collection of numbers. It can be something that is not
Yeah.
numbers. But we as a programmer, we think in data structures. Okay, okay, in function that work with these data structures. So these libraries are just they are based on mathematics, but it's really a subset of mathematics that could be efficiently implemented on today's computers. Let's say with today's languages for programming. So tensors, even though there might be some abstraction similar to matrices, just in more dimensions, the operations that you can implement efficiently are different than the operations that you use. So it is important to choose the right abstraction for your problem. My recommendation always in programming would be, and I am sure all of you understand it, and many of them would agree, to use the simplest tool for the job that can solve the job. So it means if you can solve some problem with vector and vector algorithm, use this. If
Yeah.
you have to use matrices, use them if they are right for your problem. Then if you need tensors, of course use them, but be aware that it's much more difficult to implement efficiently. So the the, 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 the set of operations that you have is different, and their implementation details are different, and their execution profile, let's say, is different. So you have to be
Yeah.
more careful. But with uncomplicated libraries today, the good stuff is that for most of these layers, we have really mature implementation. Of course, there is always
Yes.
part that I can add, but basically today, the main problem for someone who would like to try to implement something really useful and something that could
So
earn money is
yeah.
the
Yeah.
knowledge
I
of
have.
algorithms that should be
Um,
used. Not that in Clojure you cannot do it.
so when you are building a library for mathematicians, so what I found, even when I am looking at different Python libraries, the API as it is designed, it's trying to be increasingly declarative so that it resembles the syntax and concepts actually mathematicians use. And of course, mathematics is very formal. No things are added unless they are necessary. So potentially those things, those declarations you have there should be the shortest thing you might need, which sometimes might make it unreadable for people who are not as expert in certain thing. But would you say that when you are building a library, for example, for linear algebra, um, are there actually are there any practices from software development that mathematicians should adopt, like naming things, etc., to make papers more approachable or the field easier to learn?
Yeah. Well, the thing is here, maybe I'm not the right person to ask these questions. Why? Because I didn't build these libraries for mathematicians. I built
Mhm.
these libraries for me. Yeah. So I'm the main factor that I try to satisfy, which is the most difficult thing to satisfy yourself. But then I build it for Clojure. So for someone who is a programmer, certainly a programmer, but a programmer that is open for learning, open to discover better ways of doing things. So a programmer who is uh, curious beyond what is usual or most popular, but who has a really strong sense of if someone is just a way of doing things or something is the way of doing things. So to return to your question, I built this library to cover both needs. One need is when you have a mathematical description of something, which, as you said, is usually well described, as simple as it could be, clearly described without many assumptions. So really a clear thing. But the other way of looking at it, okay, but how do we make this run on a computer in an efficient manner?
Yeah.
So that in my libraries, I did a lot. I spent a lot of effort to cover both. So you have a really formula-friendly way of writing these functions. But then these functions are written in a way with overload, with polymorphism, whatever, that if you if something could be automatically decided for you, it will be automatically decided for you. But I left hooks for all these things so that if you think that you know better, you can do it.
Mm-hmm.
So I think that's the best of both worlds. So my preference is when I use my libraries to solve my own problems, I would try to stick to the simplest thing, meaning the high level, the high level function that solves everything automatically. But occasionally, I would step a level or two below to specify something that needed to be specified exactly. And then if I create a library that is also on the low level that integrates some other algorithm or library, for example, most recently I created this LLM. Illuminati is the name. Maybe you've heard about it because I just published it maybe 2 or 3 weeks
I
ago.
haven't yet.
Oh, so Illuminati is a Clojure library that runs on GPU and CPU that runs LLMs. And currently,
Yeah.
I only supported Gemma 3 because I use the general runner that is not connected to LLMs, like a general Onyx
Mm-hmm.
runtime runner that I also integrated in libraries called Diamond Onyx runtime, which is like extension of Deep Diamond that integrates Onyx runtime into Deep Diamond tensor infrastructure.
Yes.
So basically, you can export any Python code in Onyx, not only Python, from any technology, but usually people use Python for developing new models. So you can support machine learning models or statistical models or really whatever model. You can
Yeah.
export into Onyx format, and then you can load this Onyx format in that runtime, and it runs it usually quite efficiently. So we have a library to load any model. So some of the
Yeah.
LLMs are exported into Onyx, so you can load this into this Onyx runtime and run with Deep Diamond. But the thing is that LLMs are not just the LLM model. There's lots of infrastructure around it because LLM model is like the model that can generate the distribution for one token. But now, yeah, what you can do with it? So I implemented a couple of hundred lines of code, LLM extension for this Onyx, that Onyx runtime. So basically, you can load Gemma 3 and run it on a GPU or CPU. Gemma 3 is like a Google free version of Gemini, let's call it like Google's open model. So at the time when I proposed this project, like half year ago, it was the latest Google's model from 2005. But in the meantime, they published Gemma 4, which is the newest model, open model from Google. So
Yes.
that trained LLM, you can load it and then use it. And in my first measurements, it was this software that I created in just a couple hundred lines of Clojure code. Was the speed was the same speed or even a bit faster than these C++ libraries that everyone uses, like Llama C++ or so. Of course, Llama C++ can load practically any model because they specifically support it. But as a proof of concept, this is great because
Yes.
I created this using only Clojure, only my libraries. So only Clojure. You don't use any, because most of other languages libraries, even though they are meant to be used from Python, like the end user would call them through Python API. The implementation is C++ basically, and really heavy C++.
Yeah.
And here I implementing basically the same stuff, of course, with fewer features, but as a proof of concept, it is great because I show that you can get the full speed with a REPL-driven interactive development with much easier. So, but of course, the good thing is that we are not limited to this, because my next
Yeah.
idea is to start integrating these popular LLM libraries like Llama C++ or VLLM or so. No, VLLM no, because it is dependent on Python, but Tensor Runtime LLM. This is NVIDIA specialized LLM runner. So basically, the good thing is that when I finish this library, the API for this library is almost zero functions, because I integrated this in core racing. So basically, you just create flow racing channels and a process, and whatever you put in the channel, you get the result starts flowing out of your resulting channel. And I even create a demo. You can find it in the test subfolder if you are interested in. These are really simple examples. So I even created a flow integration. You know Clojure ASIC flow that Cognitive recently.
Yes.
So I didn't have any experience with flow. I just saw that flow exists. So in a couple of days at most, I implemented I learned enough flow that I integrated this library. So you just create your flow. You don't even have to think about LLMs at all to use Ilamanati. So imagine
Yes.
when I integrate, you can say now, okay, but you only support Gemma 3. It's only a proof of concept. My company would need, I don't know, Kimi 3 or DeepSeek version 6. But the next thing that I plan to do is integrate a few more mature libraries here that come with these LLM runners that come with the models already baked in. Support is already baked in. So basically, you would just use Illuminati to connect any model that exists on Hugging Face to a Clojure flow without any specific APIs. You wouldn't need to program anything specific. Everything would be out of the box. And if you got the idea, or you're curious enough to say, okay, but I would like to learn how this works so I can extend it in my custom, with my custom functions, maybe not even open source, maybe some company secret, that is the next $1 billion idea. You can do this easily because all my code is high-level Clojure code. Similar with
Yep.
Clojure. You can implement anything in Clojure. You don't need special parsers or special code generators. You just write your own higher order function or a couple of macros if you know what you're doing. That's the idea. So in these integrations, I even invented some new sampler for tokens that I plan to publish. I need to find time to write the paper, so that's why I didn't open source it yet. But I will open source it I hope in a few weeks or months. So I need to publish. I need to write a paper so no one steals my idea. Let's say so just to claim the idea, and it really works super fantastically well because it is almost free in computation in the sense uh, the baseline is 10 milliseconds. It's 10 microseconds. Sorry, 10 microseconds is the time that NVIDIA's CUDA driver needs to start any kernel. Even the empty kernel would take 5 microseconds.
Yeah.
My whole
Yeah.
algorithms, including these starting times for two kernels that I invoked, is 15 microseconds. For the whole dictionary of Java, which is 264 different tokens possible. So you have to sample that, and I do this in 15 microseconds, which is faster even than the time that NVIDIA's official library, CUDA, takes to find the maximum, the token with maximum probability. And I do the sampling, which includes much more than maximum probability. Maximum probability is just like 10% of my algorithm. So my point is here, if you see my code, this is not this is some genius code that only a genius could write, some million lines of super sophisticated code that only NVIDIA's engineers would be able to write. No, it's like 20 lines of Clojure and like 100 lines of C++ kernel code.
Yes. The whole project is about 2,500 lines of code. Um, I checked, which is awesome given how much you can do in so few lines of code. Even then, for example, the inference namespace is not trivial, definitely. Uh,
Which software
but
you're talking about? Sorry.
it's Illuminati ONNXRT and namespace, Uncomplicate Illuminati
No, okay,
internal
no, but
ONNX.
the whole Illuminati is, I think, 1,500 lines of code. It includes the code for two tokenizer
No,
integration. What?
with unit tests, it's 2,468.
Okay, with unit test, but without unit test is 1,500, and that includes the runner, all integrations about conversions of formats, all the tokenizers, all the stuff related to integration with core racing and flow. And for example,
Yes.
Deep Diamond is, if I remember correctly, maybe 3,000 lines of code, and I support several backends and lots of ready-made layers and everything. But it's only possible because I have this layered approach. Because all the 1,500 Illuminati lines of code, they are resting on the shoulders of 3,000 lines of deep diamond code. And this deep diamond code uses Neanderthals or whatever possible. So I don't implement the same thing twice. I provide one place to do it, and that place does it really well, and then you're covered forever.
Yeah. Yes. It's great how expressive Clojure is. Um, when you when you speak with people who use your libraries, um, did they start with Clojure or they just wanted to do some machine learning or mathematics stuff and found Neanderthal might be a good fit?
Well, I'm not really sure because I don't tend to ask them these questions. So actually,
Hmm.
my main problem is that people who use my library successfully, they don't tend to speak a lot about it or ask a lot about it because everything usually works and works well, and they don't have a million questions because everything works much better than they hope to, and they just continue help using it. That would be, if I was a business, that would be a really bad business because I wouldn't be able to charge much for support. But
Yes.
the thing is that the main, I can see what is the main, because that's maybe the better topic for this kind of topic. The better question, or question that would interest more people more, is what is
Yep.
the uh, major obstacle for people to use my libraries. So why don't they use it more? Because what I see in the wild, following the Clojure community and Slack and Zulip chat, whatever, is that people are mostly, whether they are coming from Clojure or another ecosystem, but they they have some contact with Clojure, so they would like to use Clojure for this. So they kind of they have an idea, or they heard that machine learning or deep learning or LLMs should be related to solving their problem. So they expect that there is some LLM library or framework that offers such and such functionality, and that they can use this framework after a few days of reading the documentation or some basic examples, and they can integrate that framework into their environment,
Yeah.
and the problem would magically be solved. And what they find out, of course, if that doesn't work, they
Yeah.
then they try to pick a framework that offers the most features that they look at. So they say, okay, does this framework has functionality of loading the data from Postgres database, or does this framework uh, can it load such and such format? These are wrong questions in my experience, but you cannot help it. People do that, or they try to see, okay, which framework has most users, which one is most popular, or which framework has the video tutorial available.
Yeah.
And usually then they run in circles for a few weeks or months, and they never, or they successfully implement some demos, but then they will see that their demo runs in like 3 hours, and they need to run in 3 seconds, and then they are lost. I don't have the
Yes.
right answer, because the point is what I said. You have to build mathematical intuition, or in this case, machine learning intuition, which involves intuition about algorithms, but also the intuition of how to use these algorithms to solve specific business problems. Because business problem is rarely defined in a way that says, okay, we need to classify these columns into these classes. So often you need to be really creative to recognize that some algorithm is a good fit for your business problem. And to be able to do that, you have to have lots of experience with these algorithms, and not in the sense of, oh, I have experience, I run notebooks that contain some trivial examples. I mean, it's an okay starting point for really the most baby step. But you have to take time to read some book. In my opinion, books, for some other people it could be like blogs or whatever is your preferred way of learning. But in my experience, it usually book offer the best in-depth explanation. Then understand these algorithms. Then try to create some toy examples, demos. But then start to try to implement some business problems, even if for hobby. And then after
Yeah.
some time of doing that, I think you will be able to, when you have a specific business problem, you go read some papers, you read some books, you read some blogs, and in a 3 day or 30 days, you have a great solution for that business problem. It's not an it's not a short path. It's not an easy part, but in my experience, is the only path that gives the effective results. Everything else is just a month or years of just running in circles, trying different libraries, trying different frameworks, trying different stuff. Everything at the beginning level, and nothing really working uh, as it should in imagination.
Yes. Yes. Another thing is for somebody who would like to learn how to use the libraries, how to do GPU development and things like that. What's the best way to do it?
Well, I can tell you how I learned. So,
Okay.
uh, when I started, there was almost nothing in the sense of tutorials and beyond the usual like hello worlds and everything similar to that. So, of course, you have to learn by doing it. Even today, when there is like
Yeah.
1,000 times more resources, still the best way is to do it to learn by doing. But, but this is what I think most programmers are taking and I'm speaking that as a teacher, not as a programmer, but as a teacher
Yeah.
who sees a lot of students trying to learn different programming topics. So yes, you have to learn by doing it. But most people start just doing it like intuitively and whatever this path uh, takes them. But as I learned what is the best way for me is to first, when I'm a beginner in some topic, to try to find at least a good enough book for the first overview. So some resource that really explain this gradually. Even though the code in the book might be lame, or even though that the book is not the best book that could possibly be written, but some book that is a good first starting point, and I try to uh, read it and try it. And by this point, I became a human compiler. So now, for the last 20 years, I don't have to type this code into my REPL or editor to process it. Now, I process it in my head. But for people who don't have that much experience, type the code. Type the code from the book. Think about it. Go beyond it. Start from the examples that they presented and try to make them better, shorter, more clever,
Yeah.
whatever. Experiment with it. Don't try to rush it. Okay, you can rush it later when you have a deadline for this particular feature. So, but at least for the first entrance into a field, please take enough time, and enough time could be a week or 6 months, depends on the topic and your ability and your uh, knowledge and like your experience generally. But take some time that is appropriate to the topic complexness and your experience, and try to really learning for the sake of learning. Like, don't think about I have to make $1 million with it, or I have to be an expert in this in a month. But try
Yeah.
to learn it just for the curiosity. and then it would be much easier to continue learning by solving problems, by earning money even, or develop commercial software. But don't force it at the start. So for
Yeah.
example, for my
Yeah.
libraries, I often hear that the main obstacle for starting with them is that they are complex. I mean, they are large, but I wouldn't agree that they are complex if compared with other libraries in the same domain. I think they are much simpler, but okay, it's a matter of opinion. But people complain that there is not enough documentation or no documentation at all, because when they go to GitHub, there is not a usual boilerplate that explains whatever today's boilerplate explains. But that's exactly why I wrote two full books with code, with everything else. So one book is 400 lines of really concise code and concise text. Another book is 300 pages of really tutorial style book. So
Yeah.
you have 900 pages not only of documentation, but of tutorial and high quality tutorial that works, that is really the real deal, not some simple examples and I pass everything. In my book,
Yeah.
Quick Learning for Programmers, I demonstrate with working code that each line can be executed in the REPL. I build Deep Diamond. So actually, one book is how to build Deep Diamond. So actually, when people complain, oh, there is not enough documentation of uncomplicated libraries, I think like, but if there is not enough documentation for uncomplicated libraries, which libraries are sufficiently documented in Clojure ecosystem? Because I don't know any other libraries in Clojure ecosystem that have have 900 pages of book level tutorial written for them, so you can gradually be hand holded and spend spoon fed, sorry, spoon fed the whole time. So, but the answer is really people don't want to pay for these tutorials, so and that's all. And they don't want
Yes.
to invest time, because even if you pay for the books, you have to read them with your REPL, which is like
Of
for,
course.
it would be a month for some people, it would be 2 weeks for some other people, it would be 6 months for some other people. You have to invest your time. So,
Yeah.
but
Yeah.
if
I'm
you can,
I'm father of two children. For me, it would be easily 3 months.
yeah. So, but my point is, okay, uh, but if it would be easier for would be buyers of these books, so you know that these books are published by me. So when you buy these books, I
Yeah.
use this money to be able to develop more open source Clojure libraries. So this is not some money that some investor would take to buy a yacht. So that all the money goes to my funds that fund the development of these libraries. And of course, if it wasn't for Clojure together, I wouldn't be able to spend so much time on perfecting these libraries, because they funded me many times in 3 month periods, where I was able to concentrate on really polishing these libraries, develop some new libraries, polish some other libraries, develop functionality backends for Neanderthal, for Diamond. So the main funds for all these libraries that you see come from these books and Clojures together, basically.
Yes.
So please, if you can afford, I mean, I'm now talking to to the viewers of your podcast.
Yes.
So please,
Yes.
if you can donate some money, you don't have to buy the books. You can just donate some smaller donation on my Patreon. So whatever way of you can, you don't even have to put any money. You can inform your friends that these libraries are there. If you use these libraries, you can publish some tutorials, publish your experience reports, how they help you, solve some problems. Uh, but if you can spare some dollar, please don't
Sure.
hesitate to donate something. Don't forget that this is multi-year project. I'm doing these libraries for the last 10 years or more. So there are many thousands of hours invested that I didn't have to invest it. I invested it for the sake of having the best possible uh, high performance computing and machine learning and deep learning computing
Yes.
ecosystem. And I think what we have in Clojure now is much better than we have in Python and other languages. Maybe not feature wise. So we support less features because there are many. But there's only me and a handful of people working on these, not my libraries, but general libraries. But in the terms of code simplicity, performance, whatever else, uncomplicated libraries can stand up to any other libraries that you choose, and they will be either faster and simpler, or at least as fast as other libraries. So you just have to
Yeah.
do them. But then the most difficult thing is that you have to have the right idea. So that the libraries won't solve your business problem for you. These are only tools that help you. This is the leverage for your mind. So still your mind.
Yes.
The main coding agents won't solve your problem for you. But
So coding
to return to public
agents.
to the pitch, please
Yes.
buy the books and learn the
Yes.
libraries and have this leverage.
Yes. Yes. Why would so for somebody who is, for example, somebody might have the rest of the application in Clojure, the web application, and so on, and there is a machine learning part, uh,
Doesn't have to be.
and they might decide to between Clojure and Python. Why would they choose Clojure, and in what
Yeah.
situations Clojure would be much better than Python?
Okay. Yeah. So I'm speaking mainly from the perspective of my libraries because I mainly use my libraries, but this is more general advice. So, for example, why would you use Python? Why would you pick Python? So, the main reason why most people pick Python, despite their build the Clojure, even Cognitect uses Python for machine learning. Not Cognitect, sorry, these new bank. Even
Nubank.
they use Python. Why? Because they employ like 200, or I'm just pulling numbers out of the hat. So I don't have any knowledge how many data scientists they have. But let's suppose they have many thousands of employees. So probably they have 100 data scientists, and all these data scientists, the only thing they know is Python. So why do they choose Python? Because that's the only thing they know. The other reason would
Yeah.
be, the other reason would be, especially for businesses. So the businesses usually like to keep their intellectual property secret, but also the other thing that they like is to take stuff for free and just use stuff for free and solve their problem and go earning more money. So usually they don't invent their own algorithms, and they usually don't have enough expertise to invent their own implementation of these algorithms, but they would use some standard clustering library in Python, or a standard classifier, or if they use deep learning, they would say, "Oh, everyone uses PyTorch, so we will train our model in PyTorch." Or they started using AI agents, and they say, "Okay, everyone uses like Python library." I mean, the implementation of these libraries in C++, but they are using it through Python. They even don't know C++. So Python offers an easy start, and often
Hmm.
offers, because they don't invent their own flavors of these algorithms. They try to use off the shelf. So they get some implementation that might not be ideal, but start, and they just continue from that. And then why would they switch to Clojure? Because by the time they put something in production, it might work in a not so good way, but it works, and they don't want to spend the developer money to make it perfect. They just say, okay, we will kick the can down the road and see where they get it. So for the people to pick Clojure for that, it would be a big step,
Yeah.
because
Yeah.
probably you will see that the algorithm that you pick is not yet implemented in Clojure, or it's implemented in Clojure, but it cannot be loaded from such and such format that someone else recorded the data in. Or it couldn't be uh, easily run on, I don't know, Google Colab or whatever these crutches are people using, because there are many crutches now, because most of people that do some data science or something like that are not really professional programmers or really skilled data engineers or so. They're like people who know some programming, know some machine learning, know some math, know some statistics, and they have an urgent problem at hand, and they have to propose a solution in 3 days or 5 days or 2 weeks or so. So they don't have the time to commit. So that's it. So basically, to try something in Clojure, you would have to at first do this as a hobby project, I think. Even today, when you think, oh, okay, there's lots of industry or companies using Clojure, I think most of these are like web dev shops or data engineering shops or startups that
Yes.
are.
Yes.
So that's why they're falling into this running in circles when it comes to machine learning, because their main competence is in let's say web dev or databases or application servers and such things.
Yeah. One thing that might actually help is you said Python is all they know. So it would help to sneak Clojure into universities or lists internal. How would you do it to sneak Clojure to more schools so more people
Ah,
will learn it?
look, the way that I snuck Clojure into university was because I had my hands were not tied, so I had full liberty to do whatever I want, because this was early in the department formation. It was early in the days of AIs and even software engineering at that time. So it was 20 years ago. So basically, I already was a professor at the time when this program was created, and I just decided uh, Clojure is great. That's the best way to teach people the stuff that need to be taught, instead of teaching them about ceremony of how to create getters, setters, or like stupid
Yeah.
things. So I decided that because I could, and when I proposed this to my mentor and department chair, he said, "Okay, I hate Lisp," because he had trauma from his Lisp days in the 80s. But he said, "Okay, I hate Lisp, but I trust you, and you know what you're doing, so do what you need, do what you think is the best." But if I weren't in such a position that basically I was my own boss and the boss of the course, it's impossible. Because why? Especially in southeastern Europe, where I live in, because students, I mean, not all students, but most of the students would avoid it. Why? Because some of the courses that I teach are elective. One is obligatory. On the master course, one is obligatory. Why? Because first, 95% of students never heard about Clojure. Even Lisp is
Hmm.
just a word that they that they heard when they were introduced in which programming languages were there like 100 years ago. So it was like
Yeah.
Lisp and COBOL and Algol and Modula and something like that. So that's the only thing about Lisp that they know. So how do they pick courses? Of course, the first thing, why did they enroll into programming and AI? Because my department is mixed programming and AI, like the best
Hmm.
of both worlds when it comes to the high potential. And
Yeah.
it's like the most popular the most popular uh, program in the whole country of any programs. So why? Because it's like for the last 10 or 15 years, it was the best jobs were there. Why do students in Eastern Europe enroll in programming so much? Because that's one of the careers that pays best. That is not like politics or
Yeah.
being corrupted corrupted cronies
I
or
understand.
political stuff.
Yes.
So basically, if you want an honest way of earning for your life in this part of the world, and so I suppose in the Czech Republic it's better, but not much different. You would want to work for a company that works for American market or Western European market, and that in Serbia is programming and IT. So that's the main reason. Next, they would look what is mentioned in the job ads, which in Serbia is Java and Python and a handful of other technologies.
Yeah.
So
TypeScript. Exactly. Yes.
so that's it. They would like to learn Python and PyTorch because that's why what Google uses or Google or OpenAI or whatever company they heard about. That's what they use for AI. And if I have that under my belt and on my CV, I can hope to find a job in some of the companies that are looking for junior developers or machine learning engineers or whatever is available on the market at the time. That's a practical choice. So basically, uh, how would you repeat what I did at my university in some other university? I doubt that you would succeed. Probably you don't stand any chance. So it's a pessimistic, but I think that's currently the situation, at least until this hype cycle about Python and AI and LLMs is bust.
Yeah. Yes. So you're right. So in the Czech Republic, but I think it will be the same everywhere. When I got to computers decades ago, uh, it was exciting because you could do new things. You were on the frontier of what's possible. Computers were getting much, much faster every year. Right? They were very expensive. When somebody got a new computer in my old town, we wanted to see what it can do. And first we had just two colors and 16 colors and 65,000 colors on our displays and so on. And uh, everybody knew that there will be money, but it wasn't the primary motivation.
Yeah,
The primary motivation really was that you can do new things. For the first time in history, you can suddenly automate something that was difficult to automate in the past. And and then companies started automating. So there was a huge demand, but it was driven like people who were doing it were people who wanted to be software engineers, not to earn a lot of money, but because there was a shortage. Salaries have grown, the developers often earn more than their managers. Uh, it's not always the case now in these times, but this is how it started. But yes, in the past 10 years, there were boot camps and people switching to development just for money. But still, to become a developer, you need certain personality. it takes years to become a good developer. To become really good developer, your formal and informal time spent programming must be at least a decade. Really, there is no way around it. I warned a couple of people when they told me, "Oh, I will become a developer. Do you do any development?" No, I don't.
Yeah.
So I told
How?
them to
How
prepare
are you
that
going
it
to
will
become
take
developer?
them. Yes. So in this, for people who are purely interested in money, uh, they will probably in the future they will not learn any programming languages. They will be just speaking to AI and building products, and they will spend more
I'm
time
not so
doing
sure about it.
marketing. And I think that actually a Clojure being a clever language, well designed, and so on, will remain one of the choices for people who care about the technology, who want to be technologists because they um, want to work with computers, automate things, understand underlying concepts in computer science. While for many people who just went to software development to build something without any interest in the underlying technology, they will most likely be just byte coding and never looking at the source code at all.
That
And
that that's the hype future, but I'm not so convinced about it. Most of these people will not get the results that they hope for with vibe coding or whatever. And I'm not even sure for how long will these main AI companies be able to sustain this level of enormous expenditure and pumping the hype balloon. So yeah, they managed to convince 99% of humanity that their next token predictors would be able to do things better than people. Uh, and I agree that for many roles that were filled with people who didn't know what they do, so they say now, okay, in experience of lots of people, Claude is now often better than the average programmer, uh, run-the-mill programmer. But my point is that maybe 2/3 of programmers didn't know what they do, so they weren't very productive. They were just faking till till they make it or so. So of course, for this kind of stuff, probably these garbage that LLMs can easily generate, it's maybe even better than what humans do. But still, there will always be problems that are not an easy and direct repetition and just rewording of something that has already been solved, but something that is not really obvious and that needs thinking to solve to solve it in an optimal way. And of course, in this thinking, LLMs could be of great help, or couldn't be of help at all. Depends on the task and whatever circumstances. But yeah, as a tool, they will be useful, obviously, very useful. But I don't think that they will be able to automate your job to think about you. And I think there is bright future for Clojure after the cycle is deflated to a normal proportion, where people see that these things work, but don't work magically and don't work for everything, and it stabilizes, and these companies cannot provide free tokens, and now your subscription is like $5,000 for whatever you did, and that would be the time that the quality of languages will return, and I think it will stabilize a bit after the hype cycle.
Yeah.
I cannot
Yeah, there
predict whether
is.
it be in a 2 years or 5 years, but definitely not 10 years. I don't think this
Yeah.
will be sustainable for 10 years or so.
So one thing, I actually I thought the same thing as you do. Um, so what changed my opinion is back in the day, AI was trained mainly on content from internet and books. Average person who writes on internet and writes books might be like IQ 115. So let's say college level, but not a genius. And I thought there will be a, let's say, a border, a gap. Sorry, a gap, a border, which is the border of possibility, and the AI will end up there, and basically you will have uh, senior experts who will be doing those expert things, novel innovations, pushing new research and so on. And they will be actually using AI for simpler jobs, and they will be doing great. And then you will have this like class of people who fake it till they make it, who didn't invest time to learn things properly and so on, and that AI will take their jobs. But those companies like Anthropic, OpenAI, they started investing billions of dollars to learn from experts. They pay them super well to show how they do their work, and they pay top experts in their fields. And suddenly you are getting into the training corpus, you are getting answers and use cases and best practices and so on from people who are on the top
Mhm.
already. And they keep training those models. So suddenly you might have a model that might behave like somebody with IQ 150 who at the same time read every single book in existence, who can read hundreds of articles and new papers, who is constantly being refreshed with new papers.
Mhm.
In a field that is like interesting for me, operations research, there is now 100 papers released every day. Nobody can read it. Like some papers are so technical that it might take multiple days to read one paper, but AI can read all of them. Uh, so in this, suddenly you are getting to the situation where even those like top people uh, might have certain skills that AI doesn't have yet, but the sheer power and ability to ingest data from many different places and fields and the massive knowledge is going to give AI also massive advantage. And it's cheap, it's super cheap. Like I have a couple of research agents running, and basically, I started estimating how powerful they are in the multiply of PhD students. Like how many PhD students are working for me,
Okay.
and how much would you have to pay them? And with AI like Anthropic Claude, you can get similar output as a PhD student for something like $50 a month. No PhD student will ever work for $50 a month.
Yeah.
This will, like those numbers will change over time. It will become even better, even more
Mhm.
clever,
Mhm.
and will constantly incorporate all those things that are learned. Top AI companies will continue spending billions of dollars learning from top experts. Those top experts, even when they basically cutting off the branch under themselves, they are paid like kings. So uh, they might not need to work anymore, but for their whole field, basically they are training massive automated competitor that can work 24/7. Uh, and this is happening, and I see it more and more that AI is giving great answers. And For example, I used to have, when I was living in the UK, I used to have a financial advisor to get advice around taxes and so on. Um, it was super expensive. It was like 300 pounds per hour.
Mhm.
Now, when I have a question about taxes, I ask deep research, and actually, I find out that I am getting very similar answers than I was getting a few years ago
Yeah,
for free, or like
yeah, that's
so.
no, that's what I said. If you use it as a tool, then great. For example, maybe before you had to, I mean, like basic Google search worked much better before LLM. Like you could actually find stuff on Google. But if you have something really specific, you have to visit like 100 pages, different pages on the internet to read them, to integrate this. Nowadays, you will probably type your query into one of the LLMs and say, okay, find this for me. And often they will find maybe even a better summary that you could find yourself in 5 hours of
Yeah.
Google search or whatever. But there are two things. First, while you were searching yourself and reading these answers to your problem or whatever data, you were thinking about the problem. So often in these 5 hours, you develop your own solution, maybe even a business idea or whatever. Now you will ask Gemini or Claude or whatever you're using. It will give you some answer. Half of the answer may be hallucination. You wouldn't know it unless you really go there and check this stuff. But okay, you will have your answer. You will have this basic level of knowledge, let's say it now. You will forget it in 5 minutes and go to different shiny stuff that interests you. So, for example, let's continue with the topic of financial advice. Of course, if you only ask the human financial advisor, he might even give you a good answer for your money. You never know. LLM might give you a better answer, but if you are, let's say, an investor who likes to devise your own strategy, you would probably listen to that advisor. You would read some book from time to time. You will follow the market, and you would develop some intuition about investing. So your investment strategy would be your own. If you're good, probably it would be a good strategy. But now, if you only ask Claude, you would get similar investment strategies as everyone else. And as the
So
investment market is like a game and everyone has the same advice. It might be a good thing, but you may be just going towards the average. Of course, in investing, it is a question whether you can beat the market at all. So, however, you are smart. So probably with investing, it might be great. But for example, in developing your business idea, okay,
yeah.
you can ask Claude for a million business idea, and it will give you a million good business ideas. But these are the same business idea that everyone else is getting. So for your own stuff, to do something
Yeah.
different,
So
something that is needed in the market, that is something that has to be for a lots of people something unique to you. Because if you are offering to the market the thing that everyone else is offering, the only way you can win is to be the biggest player.
yeah, yeah.
Or
So speaking of which, I I partially agree that like if you did not add any context, you would get the same answer. But and of course you have to read. I think actually since I read a lot all my life, but since AI has started, I think I read even more than ever. And uh, I had I had so many business ideas in my life, and many of them failed. And actually, if I had a tool that would do much better research of most of the time competition or reachability of buyers, this is where I typically do mistakes. Uh, I would I would save myself years of my life, lots of money. Speaking of, for example, investments, yeah, I have like my retirement savings and I have built a portfolio. Also with help of ChatGPT, but I created what if scenarios of what I think will happen to the world. I have to calculate how likely those things are based on available data. Then we run a simulation in Python, like some optimizing model, and I arrived at portfolio that should be on par with SP500, but the biggest drawdown is about 30%, while SP500 falls 50%. And for example, with this portfolio, this year I am 24.6% up with my retirement savings. I know it's not going to be like this, but I should be on par with SP500. I know it's hard to beat it, but my risk should be lower. It's backtested and there are incorporated certain what if scenarios connected to the risks of war, aging population, inflation, and other things. So it also depends a lot on how you use AI, what you feed it with, how clever are your prompts.
Well, that's what I said. I mean, if you use it as a tool, as some sort of superpowered, superpowered search, or some sort of, I wouldn't say your assistant, because it would give it too much of anthropomorphization. But whatever way you use it, if you are using with understanding that it is not an intelligent being that is giving you uh, uh, how how do I don't I cannot find right words, but don't give it too much power to think. Don't outsource your thinking. Is I think the best
Yeah.
explanation. So if you are using it as an input for your own thinking, then great. But if people hope that they will just put 1,000 agents to work on them, and they will sit on the beach, and their investment portfolio will grow immensely because they have a super intelligent investor employed. I think they will find with $0 after some time, because even if these agents could do the work perfectly, if everyone is using them, uh, in the total, you will get wiped out. So that's it.
Yes. In this, of course, you should not stop using your brain. You should use
Yeah.
the brain as much as possible. AI might be great to get do a research for you, so you get much more data that you would get anyway. It's still your responsibility to read it. Say if you believe those outputs or not, because of course AI might have biases, do mistakes, and so on. Or on the other side, you must be the one who is driving those agents, because like AI itself, like if you ask AI build a business, make no mistake, earn $1 million, it's
Yeah.
going to fail.
Write perfect
It's
code,
going
make
to
no
fail.
mistake, make $1 million. Yeah.
Yes, yes.
It doesn't
It's
work like
going to
that.
fail, of
It
course.
doesn't work like that. And also,
Yeah. Uh,
the usual answer is like, you ask the question, it lies to you. You say, but I checked the answer. It's wrong. Why did you lie to me? Oh, sorry. Oh, sorry. I lied to you. You were right.
yes, yes. So It doesn't remove the responsibility, of course, of
Yeah.
users. Um,
And
Also, I think that different people like one disadvantage is that it is too agreeable. So whatever you ask, it's trying to confirm your thoughts.
yeah, but I think
And
this is inevitable because it doesn't think. It just generates tokens that are likely to be the answer to whatever it's needed. And of course,
it
this token generation is not completely random. But the point is, it tries to write some text that you will be satisfied with, and that's one of the answer why it's so agreeable. I mean, it's not
yeah.
agreeable. It just generates those sentences that are agreeable to you.
So I think it must be
I'm sorry. I'm
also
sorry.
like
I have only 18% battery left.
okay,
So we
okay,
may have maybe 10 minutes more, or so I don't know.
okay,
Maybe 20
okay.
minutes. So
Yeah, I think one part why it is so agreeable might be because it drives engagement, because people feel good when somebody
yeah,
agrees with them. So if you have like two companies, one company would build AI agent that's very agreeable and confirms everything you think, and the other company would have an agent that's completely realistic that pushes back every time you say something that's not true. People would gravitate toward the first one even when it's irrational,
yeah,
and it's a shame. I try, like I have it in my like personal prompts and in the tone that I want it to be strict, to push back, to call out when I say something that's not true, and so on. But still, it's too much of a yes man. No matter how hard I try.
yeah. You asked it to not
Uh,
make any errors, and it still makes errors.
Yes, yes. And this is just one part of the problem, really. For example, most of the ideas people have are actually bad ideas, and pursuing them might be a waste of time. Um, like when I before I buy anything, like when I don't know if I want to buy something, I put it to my to-do list with a deadline 30 days. And only if still after 30 days I want to buy it, then I go and buy it. Uh, even for humans, our ideas are not good ideas, and 1 month later we are not interested in them anymore. Um, and we end up with lots of things at home. With AI, it's probably the same, but because they confirm you, oh, you should build this, you should build that, it will be awesome, millions of people will use it. That's not true, they will not use it, they will use their own vibe coded version of whatever, or they will do something else completely. It's uh, it's definitely a risk, and it might lead to like overbuilding things that are not actually needed, for example, in software, uh, or writing too long texts when actually it's not needed as well.
Yeah,
Yes, interesting times, isn't it?
yeah. I think one of the main problem would be, i- let's say that these tools start working as advertised. So you really get a decent enough automatic programmer that you put on the task, and it will develop a program that works. So what is the future then? Like there would be a billion people who put their agents to work and develop tens of billions of applications. Who would use these applications? Okay, AI company said, but the agents will use these applications. Yeah, of course, but then if you create some applications, or let's say you're a business, uh, or you create this as a business to earn money, then
Yeah,
who will pay for these applications when everyone can just put their agents to create these applications for their staff? So it's the same problem as we see now as text. As I said 2 hours ago, 15 years ago, there was not so much content on the internet, but this content that was there was not polished at all. But
Yeah.
most of it was kind of worth reading, at least skimming, because you could get a some interesting application that inspires more research, reading some book or going to some forum and read what they have to say. So it was not polished, but it was authentic. Then there came these spam blog posts about recipes and everything else. That was the first way that completely destroyed whatever you could read on the internet. And now we got this automated to the max. Like there is tons of content about whatever you imagine now, but like almost 100% of this is complete crap. Maybe it's polished.
Yeah.
Maybe it looks often it looks quite at the first glance it even looks high highly produced, or how to say it. But if when you start watching it or reading it, you see that it's like most empty sentences. Like in the old Greek philosophy, there were philosophers. Like philosophers, maybe people that don't uh, speak in flowery language, that are not really polite, that are not agreeable at all,
Yeah.
but they had something to say. They were worth
Yes.
at least listening to and thinking it, even if you don't agree with them, their perspective is inspiring. But the topics were like people who were like demagogues, like speaking in nice flowery language, agreeing with you, wherever else,
Yeah.
it's empty words. So it's now I think our future will get this to the max. Like you know this professor at university or at school or whatever could or a student who could really learn a book by heart. So they can
Yes.
speak for hours. They can repeat everything, really nice language, really good choice of words. But you say, okay, but it's not interesting. It's not something that I need. You could set this in 2 sentences. That's what I'm talking about. So
Yes.
whoever
Yes.
finds the solution, whoever finds the solution to this problem has my money. I mean, I don't have a lot
It's
of
true.
money, but I prepare.
There is now a lot of slop or things that are unnecessarily long that could be expressed in less agreeable and less polished way, but still get to the point much better. I generally I try not to read um, any AI output except AI output I generated myself. I'm not interested in output of other people's prompts,
Yeah. So that's one
and
of the main business challenges of all people who think that they will produce a lot of AI content without much effort, and that other people will somehow use it, because everyone wants to produce content for free, and no one wants to consume it, at least
yeah.
willingly. At least willingly.
So yeah, I think people consume a lot of content, but um, content like AI slop, generic AI slop, it's definitely not pleasant to consume at all.
So
Okay, I know you are
sometimes
running. Yeah,
it could even be pleasant at the surface. I mean, I've seen people watching AI slop generated like videos of nature, and I was surprised. I was like, "Whoa, this is like this is AI generated," but they put it in the background. It's a nice environment, so they don't mind. But they usually don't want to pay for it, so they just consume it in some background. Like,
yeah, yes, yes, absolutely. Um, I would like to thank you. And the last question is, how can people support you?
Oh, thank you for this invitation. Thank you for great questions. I may not have answered them in the most interesting way, but I hope your viewers will find it possible. So, uh, if you want to support, first you have to know what I do. I develop lots of Clojure libraries for high performance computing, for deep learning, for linear algebra, for CUDA programming, for OpenCL programming, for functional programming. Lately, even for using LLMs for good purposes. And one of the ideas that I will try to do as an open source project is to develop a software for automatically detect AI bloat. So I have a really concrete idea, and I will not develop this as some sort of lower $1 billion idea, but as an open source solution. And I hope that I will be able to fund this just as an open source without hiding anything. But this is some future. But right now, I'm developing these libraries that everyone, these are all open source libraries that everyone can use. And they're especially targeted for Clojures, but not limited to. These are really high speed stuff, like the fastest in the world that you will find in this kind of software. And I found this, uh, as I said, Clojures together help me from time to time. Often I have to thank them many times. So they were really the greatest supporter, and I get some really small money. It's really not much from some occasional donations and books that I wrote. These are high quality books, not some things that I wrote because I had to, because I wrote them because I wanted to.
Hmm.
As I know, English is not my first language, so they are not the English in there is not the most perfect English that you could find in the literature. So I'm definitely not Shakespeare. But the language there, as people told me, is more than good enough for technical level, and it's really two books without any bloat.
Yeah.
Every line is manually written and tried by me. Each line worked in your REPL. These are written as tutorials, and you can buy them uh, on my Patreon on aibook.com. These two
Hmm.
books will teach you a lot about not only my libraries, but about underlying principles of high performance writing high performance code. But high performance code that is still really elegant code in the Clojure sense. So I explain
Yeah.
both programming and machine learning and maths there. So yeah, these books are really some that I would recommend, not because I get some money when you buy them, but I really think that any Clojure programmer that reads them will be much better, even with Python libraries. Even if you don't use Clojure for this, you will understand PyTorch and NumPy much more than you do if you come from the usual Clojure web development background or database or data engineering. So uh, you can also hire me, but like I'm not an affordable programmer for East Europe, so probably you would hire me if you really got some advanced problem to solve, which I imagine most Clojure companies wouldn't have. So yes, I'm open to engagements to work with you, but not as cheap labor, so probably not that attractive to you. So the best way to support me is to uh, talk about my libraries, to try them, to talk about your experience, to buy my books, and donate some money that you can spare on some Patreons. So will be really
Okay.
helpful. So you know that all this money goes into developing these libraries. I don't use this money to like go to Tahiti for 3 months or so. So
I would love to go to Tahiti one day. Okay. Thank you very much. It was a pleasure having you, and let's speak again in the future.
yeah, definitely call me anytime that you have space to give me in your podcast and other podcasts. I like this experience a lot. So you were a great host, and I recommend other closure people when Jerzy calls you. It's a good idea to answer.
Okay,
Okay,
perfect.
bye.
Thank you very much.
Thank you. Bye.